In this lesson, I will discuss how to get started with R. We'll start with how to install R and RStudio. We'll discuss the interface a bit, and we'll start writing a bit of R code to see some of the capabilities of the program. So you may be new to R, and may be wondering, what is it all about? R is a programming language that is used for statistical computing and graphics. Now, RStudio is an integrated development environment, an IDE, basically a point-and-click collection of tools where you can run R commands, view figures, import data, and organize projects. The first thing you should do is download and install these programs. One thing to note is that you should install R first. Once R is fully installed, then install RStudio. Once everything is installed, open RStudio. You will see three panels. The console panel. This is where R commands are entered and output is presented. The environment. This is where variables, functions, datasets, and other objects are listed. And the general panel. This is a multi-use panel which we'll use for various things. We will often use a fourth panel called the source panel. This allows us to write a script of commands prior to running them. To view the source panel, click on the icon at the top of the console panel. Scripts written in the source panel can be saved or loaded as needed. Generally, we'll consider it to be good practice to write R code in the source panel and run it line by line. To run code on a line in a script, either click the Run icon or Control-Enter on PCs or Command-Enter on Macs. Let's get started writing some R code. Okay, so here we are in R. And we see the three panels. We see the console panel, the environment panel, and the general use panel down here. I want to point out just a few things with that. One thing is that if I type something in here, I type in a command in R, let's just do something like 5 times 3, and I run that. Notice how that shows up here in the History tab. And so I can easily keep up with the various commands that I've run over here. Down here in the multi-use panel, if you click on the Help tab, then this is an easy way of getting help with R. For example, if we want to find some information about the mean command, I can type in mean, and it shows me all I need to know about this command, how to run it, what arguments go into it, and all of that. I'm going to open up the source panel up here. I'm going to click on this little icon, and that has opened up my source panel, and I'm going to open up a script that I've written for this. So in this script, we're going to work through a few different things. We're going to get to know R and see some of the different capabilities of it. So the first thing I want to point out is that if you want to put a comment in your script, you precede it with a hashtag. R will ignore anything that comes after a hashtag. It's just a comment. And I think it's a good idea to write comments in your scripts just to keep things organized, and you can keep up with which actions are being done in your script. Now, one way of thinking about R is as an enhanced calculator. It can do addition. So here I've got the command 2 plus 2. When I run that, I can see that it adds those. It gives me 4. It can do multiplication pretty easily. Exponents, -3 quantity raised to the second power. If I run that, then I get 9. Now, one thing I'll point out down here is that in the output, you see there's a bracket here with a 1 inside of it. That can be ignored. That's really just saying that this is line number 1 of the output. And if you have something that's really long, then you may have more than one line. We can do rational exponents in R, 100 raised to the 1/2, which is the same thing as the square root of 100. If we run that, we can get it. There's also a square root command that you can run. You can do e raised to a power. That's with the exp command. You can also do cosine pi over 3, trigonometric values, and we see that all that is pretty straightforward. R can do logic operators. It will return a true or a false based on whether the statement is true or false. For example, 4 is less than 10. That's a true statement. So when I run that, I see that it returns true. 7 is equal to 7. And notice the way that R uses the equivalent command here. It's equals equals. So 7 is equal to 7. Well, that's a true statement. How about 5 is less than 2? Well, we know that to be false. When we run that in R, we see that it will return a false. 8 is less than or equal to 8. And again, note how this is inputted. It's a less than followed by an equal sign. And because 8 is less than or equal to 8, we see that this will give us a true. 3 is not equal to 4, and note how this is inputted. Not equal to is an exclamation point followed by an equal sign. And because 3 is not equal to 4, we get true. Here we have a compound statement. The AND sign right here says that both of these things must be true in order for it to return a true value. And we have 2 is less than 4 and 13 is less than 10. Because 13 is not less than 10, we expect to get a false value here, and that's exactly what we get. The OR operator says that it will return a true if either one of these is true. And so we have 2 is less than 4 or 13 is less than 10. Because 2 is less than 4, when we run this, we see that we get a true. We can make variable assignments. We do that using the assignment operator. That is a less than sign followed by a hyphen. Suppose that we want to define a variable, var.1, and we will enter the value 12 into that variable. Then we would do that with this type of command right here. 12 is assigned to the value of var.1. And if we call up what's in var.1, we see that it returns 12. Let's assign 8 to var.2. And if we call up var.2, it returns 8. Well, now that R knows that var.1 is 12 and var.2 is 8, we can use those variables in other operations. For example, let's define a new variable, sum.of.vars, and this will be var.1 plus var.2. At this point, the assignment has been made. Now let's see what that value is. It's exactly what we expect it to be, 12 plus 8, which gives us 20. Suppose that we want to define a data array, that is just a list of numbers, like a data set. Suppose that we have the array comprised of values 1, 2, 3, 4, and 5. Now the way we put this into R is C, open parentheses, and then we put in each of these values followed by commas, and then we close out the parentheses. So let's define the variable data.set.1, and in that variable, we will assign the data array, which is comprised of the values 1, 2, 3, 4, and 5. So let's run that. And so let's call up data.set.1 and see what's in there. And it returns exactly what we expect, 1, 2, 3, 4, and 5. Now let's assign another data set comprising the values 5, 2, 0, 9, and 15. We'll call this data.set.2. Okay, so we have dataset1 and dataset2 defined. We can now perform element-wise operations on the datasets. For example, dataset1 plus dataset2 will add the first elements and the second elements, and so forth. We see that we get 6, 4, 3, 13, and 20. We can subtract dataset2 from dataset1, or we can multiply the elements in dataset1 by the elements in dataset2. Suppose that we wanted e raised to each of the values in dataset2. We can do that with the exp command. Now let me point out something here. Note that the output is in scientific notation. For example, the value 1.484132 EO2 is really equivalent to 148.4132. The EO2 indicates that we should move the decimal 2 places to the right. Let's take the square root of all the values in dataset 1. Okay, so all those examples involved element-wise operations. We can also perform operations on an array itself. For example, suppose that we want the sum of all the values in dataset 1. We do that with the sum command. We can find the mean of all the values in dataset 2. Let's find the length of dataset 2. Now what this will do is it will return how many values there are in that array. And we see that there are 5. Now, let's talk about how to import data. If you have a local file, then there is an import dataset tool in the environment that facilitates this. More often, we will be importing data from online. Before we begin, I'm going to load the reader package, which facilitates the importing of data. I do this using the command library reader. One useful command in this package is the read.csv function. If we have the link address to a comma-separated values file, a .csv file, then this command will load it into R so that we can use it. I'm going to head over to my website, www.barrymonk.com, and click on the Datasets tab. Here we have the links to a number of datasets. Let's right-click on the Bigfoot temperature and moon phase dataset and copy the link address. Now, back in RStudio, I want to read in this data. I'll start by naming the dataset Bigfoot, and then using the read.csv command to import it. Note here that the link must be in quotations. Now let's view this dataset using the view command. Note here that the V is capitalized. So here we see the data. This dataset is comprised of alleged Bigfoot sightings, their locations, dates, and the temperature and moon phase at the time of the supposed sighting. We can see that there are 3,027 sightings in this dataset. Take note of the variable names: state, date, temp, and moon phase. Let's play around with this dataset a little. First of all, to reference the dataset, we just enter the dataset name, Bigfoot. To reference a variable in the dataset, we enter the dataset name, followed by a $sign. At this point, R lists the variables in the dataset. Let's choose state. We'll get into the details of this command later, but for now, let's just use the table command on the variable state. This command creates a table that shows how many sightings occurred in each state. So, suppose now that we wanted to know the mean temperature at the time of all of the Bigfoot sightings. We use mean Bigfoot $temp to find the mean temperature. It's approximately 67.278. Now, any of the operations mentioned earlier can be performed on the variables in our dataset. I'm not sure why we might want to do it in this case, but we could, say, multiply the temperature values by the moon phase values. The thing to remember here is that once a dataset is loaded, to access a variable, use the form dataset $variable. Now, it is possible to attach a dataset to your workspace. Doing so will make the variables immediately available without having to preface them with the dataset name. Let's attach the Bigfoot dataset using the attach Bigfoot command. This makes the variables state, date, temp, and moon phase available to be called just using their names. Say that we now wanted to find the mean of the moon phase variable. We just enter mean moon phase. If you're only working with one dataset, attaching it to the workspace may be helpful. If you're working with more than one dataset at a time, it's probably best not to attach them, particularly if any of the datasets share variable names. Lastly, just as you can attach a dataset, you can also detach it using the detach command. If we detach the Bigfoot dataset, then you can see that we can no longer call the variables just using their names. We must preface the variable names with the dataset and $sign to access them now. Okay, so that's it for this lesson. In the next lesson, we'll talk about how to generate a report that incorporates R commands, output, various formatting options, and commentary using R Markdown.